Welcome to Check on Learning 6.2. Let's begin. So we're going to start off our Check on Learning with a proof. So it's a show that these two things equal each other. And judging by what I'm looking at here, you can't just shove them both into a calculator and come up with the same number. They want to do it the hard way. So let's go. First of all, we've got the, so we start here, that's given, and then the right side stays the same, and looks like we brought the powers outside of the parentheses, so we have 6 to the 1/3 on the inside. Power of a power property. I'll go with that because they're essentially doing the opposite of it. Definition of the second power. So we've got second power here. So that would be defined as this number times that number again. So we expanded, oh, come on, pencil. So we expanded this. So then we need to expand this guy. If this was the definition of a second power, oh look, definition of a fourth power. This is a really weird way to do this proof. I would still just shove it all in the calculator. The associative property of multiplication. That's back from a while ago, right? Probably learned that in Algebra 1 or something. So the associative property means that you can move these things around, and since it's all multiplied, you can get rid of the parentheses and things like that. And then we've got 6 of these things lined up in a row, so we can say the definition of the 6th power. So this proof is weird because it's got numbers in it. Had this not had numbers in it, then the rest of the stuff would make sense. But since there's numbers in it, like, just plug it into a calculator. Duh. But anyway, that's what they were looking for. Oh, man. Simplify the expression, justify each step. Here I thought it was just simplify the expression, and we'd be good to go. But no. So the first thing we do, I would add my powers together to get 8 to the power of 6/3. And so that would be the quotient, the product of powers property, because that is a product, and that would equal, there you go. I did that part in my head, so whatever. So then we simplify the exponent. So that's going to be, so 2/3 plus 4/3 equals 6/3, which also equals 2. So then we have 8 squared. Evaluate the exponent, bam, and we're done. Good job. Oh, this is so cool. Simplify the expression. Oh, we have to justify each step. That's gross. Because there's so many different ways that you could start. Well, let's see what they got. And actually, I guess it doesn't matter. So no matter what, you should start on the inside of the parenthesis. I'm gonna start on the top because I can. Can I? Is there anything we can do with that? So I just noticed that it's an X and a Y, which means we can't really combine those. But what we can do is we can combine these. So let's start with that. So let's see here. The quotient of power property means that that is going to be 2/3 minus 1/3. They both have a common denominator, which is 2 minus 1 over 3, so 1/3. So then our whole thing is going to be y to the 1/3 times x to the 3/2 times that part. So that's what we're looking for. X report. Okay, yeah. And then we simplified the exponent. Okay, so now we're there. So now we're going to take the power of a power property. Power of a power. Sounds kind of cool. So you're going to be multiplying this 3/4 to each one of these. So I'm assuming they have this guy here. And I'm just going to go ahead and do the fractional math here. So 3 over 2 times 3 over 4, that's this part right here. 9 over 8, can't simplify that. Then we got this part, 1/3 times 3/4. We're going to have 3 over 12, which equals 1 over 4? Yeah. So, looks like this is going to be our guy. That's a weird answer. 6 over 6, you wouldn't have that. And that's just not their answer. So, whoop! There you go. Done. Simplify the expression. Justify each step. I really would just rather do that myself, but let's justify each step. So they started here. We'll zoom in just a little bit. These are getting smaller. We started here, went to there. So it looks like we just divided the cubed root up. Quotient property of roots. How about that? So I guess 32 is going to be a perfect cube, because I totally knew that off the top of my head. So let's just double check that. It's the cubed root of 32, right? So here's my calculator. So remember, to do a cubed root, you do have to use some of your properties. What number are we doing again? 32. So 32 to the power of 1/3 is not a happy number. So, they did some factoring and stuff. So I'm looking down here at some of their answers. So I'm looking for perfect cubes that got factored out. So a perfect cube, I feel like that x could come out. That would be an x squared. So let's look at this guy. Come on. There you go. So a 2, so 2 times 2 is 4, times 2 is 8. So 32. So they divided that up into 8 times 4. So that would be like square root of 8, I'm sorry, cube root times cube root of 4, which is 32, and then this turns into 2. And then on the bottom, they pulled out an x cubed, which turned into an x, which left that one x cubed there. Okay, cool. So we factored out some perfect cubes. Simplified the roots. Where did we simplify the roots? So we got an x squared on top, an x on bottom. Okay. Oh, wait. How did that x squared get back in there? No, I don't like that one. Let's see here. Simplifying the roots. Did I miss a step? All right. So question 4. So number 2. Oh, okay. So that's the problem with doing these proofs on this program is, I mean, I can do the whole thing, but trying to figure out what they're looking for can be challenging at times. So they're going for this guy right here. So they factored everything out inside of the cubes. And then after that, they simplified the roots into this. So then rationalize the denominator. That's that guy. I know that because we're multiplying by a fancy version of 1. Product property of roots. What do we have left? So then we've got both cubes. They're getting multiplied together. So here we go. So if you look on the bottom here, we have our x here and our x squared multiplied together with under our cube roots. So we're going to add those together. That's where that 3 comes from. And then on the top here, that just all gets multiplied together. So then we're going to simplify the roots. Notice how we have a cubed root of a x cubed. So that goes there. Then we have an x and an x. So then this goes there. So the problem itself, I would want you to be able to simplify this expression. You will not have to justify everything from here. So just so we're tracking on my expectations on you. All right, one more. Let's do it. Obviously, we need a word problem. So Annie and Sarah both invest money that earn interest compounded annually. Annie's investment in dollars can be represented by that. Sarah's investment in dollars can be represented by that. How many times greater is Annie's investment than Sarah's? Enter the actual comparison and then estimate to the nearest hundredth. So how many times greater is Annie's investment than Sarah's? So at the end of this, we're going to be able to say Annie's is blank times more than Sarah's investment. So to find that, we are going to take a ratio. So it's Annie's to Sarah's. Annie's investment is 1,000, 1.02 to the power of 11 over 6. That's a terrible looking 6. Over 500, 1.02 to the power of 27 over 12. Okay, so right off the bat, I'm going to simplify this and that. So I'm going to basically cancel out a 500, which is going to leave me with 2, 1.02, 11 over 6, over 1.02, 27 over 12. So our quotient rule says that we can just subtract the fractions. So we've got 11 over 6 minus 27 over 12, which is also equal to 22 over 12 minus 27 over 12, which is equal to negative 5 over 12. So now we're going to go into red up here. So we're going to have 2 times 1.02 times, or I'm sorry, raised to the power of negative 5 over 12, which is also equal to 2 over 1.02 to the power of 5 over, come on pencil, don't fail me now, we're almost there, 5 over 12. Now the question is, will they take that? I don't know. Let's see what they will take. Yeah, so then over here, you're going to, so the actual is, let's see here, we got a fraction, so 2 over 1.02. Notice how I'm using the parentheses. Parentheses are your friend. 5 divided by 12. So the estimated, we're going to plug that into a calculator, right? Where did my calculator go? There you are. So this is the only thing that we are plugging in. And again, make sure you use parentheses to make sure that your calculator is doing exactly what you want it to do. So let's get rid of that. 2 divided by parentheses, because I want all this to be done, 1.02. Now, if you had an older calculator, I would have another set of parentheses for my power. Oops, that's not what I wanted. By the way, this delete button deletes the one thing that is selected, or the next thing back. So if you make a mistake, that's how you can do it. We gotta go out and finish my parentheses, and we should be good to go. So our answer is 1. I forgot how many decimal places they wanted us to go, but I'm just gonna write down this number and see what they said. Round to the nearest hundredth, 10th, hundredth, so 1.98. So about 1.98 times more. So Annie's investment is 1.98 times more than Sarah's. So there you go. Practical application in finance. By the way, if you go into finance, you will make way more money than me. But you don't get to hang out with people as much. So there's that. So that is our check on learning. Good job, and I will see you in class.